Next up, we have Jason Bremner from Qualcomm. Great. So, welcome, Jason. Here's Mike.
Thank you. So I guess I should start by saying this is my first Maker Faire, and I've already learned a heck of a lot from Era. Clearly, I came without enough boomerangs or hovercrafts or drones, so next time I'll bring more trinkets. But my name is Jason Bremner. I work for Qualcomm, a chipset company based in San Diego. Some of you may or may not be familiar with the company, but I'm sure you're familiar with our products. We make the semiconductors that go into most of the mobile phones you're using today, both the application processor and the modem baseband. And I'm going to spend a little bit of time today kind of talking about what's happening in the mobile industry in particular, how that can be applied to the maker world in particular, and then share with you guys some concepts and some product announcements that we're launching today at Maker Faire, which I think you guys can take advantage of. So the first thing we do is when we talk about to this week and this day is actually about inspiration and innovation. And when I think about innovation, it really comes down to two big classes or types of innovation. The first is when you really invent something new. Think of Thomas Edison inventing the light bulb, or the Wright brothers designing the first flying machine. The second is more of an improvement, taking something that's already known, existing, doing it slightly differently, or solving the same problem a different way. And so you can invent or improve, and those can both be products-based or process-based. So a lot of parts of innovation don't necessarily involve a physical thing. They involve the way you do business, your processes, your manufacturing capabilities, your human resources. All those things come into play when you talk about innovation. Qualcomm, we have, it's a fairly large company. We have about 27,000 employees around the world. But we are predominantly a bunch of tinkers and makers at heart. And we spend a lot of time focusing on our skill sets and our talent base around trying to innovate the next thing. And sometimes there are huge step functions in technology advancements for mobile technology. And sometimes, more than often than not, there are little micro moves. But the environment that we've created is not by accident. It's intentional, and we spend a lot of time at Qualcomm focusing on trying to make our employees more innovative day to day. So there's kind of four key areas, I think four key kind of ingredients, I would call them, for innovation that we focus on at, with any company, basically. The first is environment. And this does not mean, putting a ping pong table in the workplace. That's not kind of creating an innovative environment. This is more about creating the tools and resources and the technology from which people can actually build an innovation. Creativity, so clearly we all have to have the creativity, whether it's in the human resources that we have on team or in the company, or whether it's the financial resources to kind of stroke the creativity. And then the capability, and oftentimes that comes down to, in our case, for example, it's heavily dependent on the technology. It's technology and people. So the ability to develop the technology, but also have the resources to kind of realize that technology through engineering services. And the last, I guess, is inspiration. And that's that spark or that drive or the need to solve a problem. I think everybody here today at this conference this week is really here because you're trying to solve a problem or you're inspired to do that. And you can't really mandate that or legislate that. It's something that you kind of has to come from within, and there's got to be a common focus. And it doesn't matter how big your group is. It could be a set of 2 or a set of 2,000. But you have to have that common need to solve problems. And that's really what we focused on. If you look at the mobile industry, in particular, we have some really crappy design constraints in the mobile world. Power, thermal, memory, performance are really design constraints that from the outset we've had to kind of manage. And unfortunately they all work against each other. So when we're trying to design the next application processor modem chip, we have to keep these four continuum at play. And it's very tough to kind of find the equal balance between all four of them. Having said that, it gives us a huge advantage to take what we've done in the mobile world and kind of apply it to new markets, in particular the Internet of Everything or Internet of Things, and in particular the maker world. And I'm going to kind of talk through some of those advances that we've done. If you look at the mobile space, so let's just take a look at the last, say, 7 to 8 years, and a snapshot of the type of advancements and innovations that's happened. You know, in 2008, we launched the first Android phone with Google. It was a very simple ARM-based application. It had very, you know, low uplink and downlink beta rates. We didn't even have video recording at that time. We had simple 3-megapixel camera. 8 short years later, across all these criteria, talk time, processor speed, uplink, downlink, video playback, resolution support, graphics capability, factor of 3 to over 100 times performance improvement. And again, that's not kind of a consistent step function in innovation. That's a lot of mini moves to get to a big place. But that curve is really settling off, and I think as a consumers, you guys are seeing that, right? The resolution war has kind of settled down. The megapixel battle is kind of played its out. So we're starting to see a slowdown in these big step innovations in mobile technology. What's replacing that, for us, we're spending a lot more time on taking the existing components within the chipset and using them in a slightly different way. So back to the whole, you know, invent versus improve, we're really focusing on taking what we already have in silicon and using it in a different manner to offer new experiences to device manufacturers. In the phone today, huge amount of power. If you look at each component that we have to integrate, there's oops, sorry. Did you go back one? There you go. Oh, I think you're missing a slide in that one. Okay. The processing power in a cell phone has a lot of different components. You know, the average battery has about 20 to 30 kilojoules of energy in every phone. That's enough energy to kind of lift myself up 8 to 10 stories. The CPU processor, typically 1.2 to 2 gigahertz, quad-core, octa-core, more processing power than the average, you know, supercomputer in the early 80s. The graphics performance is getting up to where console gaming is in terms of performance and resolution. And underlying all that is the capability of, you know, replacing your camera, your camcorder, your DVR, your GPS standalone device, all integrated into one device. So already in the phone, which is the most widely adopted platform in the world, there's a huge amount of processing capability. We just have to figure out how to harness it in a different way to establish new markets. And when we look at the IoT market, we kind of divide it in these 2 major categories. Those products that need to have IP connectivity. So in these cases, you're looking at very simple products, light switches, you know, thermostats, very low sensory capability. Really their job is to get point data and push it up back to the cloud. And the second category is the smart devices. And the smart devices are much richer in terms of multimedia performance, much higher complexity in terms of software and hardware. They sometimes have contextual awareness. Their sensory capability is much higher. And they're usually doing on-device analytics. That requirements list, if you look at the smart devices, is exactly the same as the mobile phone technology. And so one of the things that we're doing a lot at Qualcomm is trying to match up those requirements in our mobile phone portfolio to enter these new markets. So what are we doing here today? Clearly we recognize the linkage between our investment in R&D and how does it get to the market? I mean, how does it get to a real product? Traditionally, we'll work with OEMs, the handset manufacturers of the world. But in order for us to kind of expand these new markets, we have to expand and work with the companies that are truly doing the innovation. You know, Gartner put out a report a few months ago, and it basically said that in 3 years from now, half of all the devices made for Internet of Things are going to come from companies that are less than 3 years old. So that means a large part of the innovation in this new market is going to come from folks like yourself and smaller, more nimble, kind of fast-moving companies. So it's really important for us to start to engage more actively and also give you, the guys, the tools and the platforms that you can start building your technologies and services on top of the Snapdragon platforms. These are some of the examples of R&D. At Qualcomm, you know, we've spent about $33 billion in research and development. We've pumped that largely back into our ASIC company division. Now we're doing a lot of R&D on software development. And we're not only, you know, getting that to developers through DKs and development kits, but oftentimes we're actually open sourcing it. Gonna quick 4 videos here, kind of go through each one of what we're doing. On the upper left-hand corner, we have a drone running on a commercially available smartphone. It's not only being controlled in terms of the flight, the flight control system, but it's actually being able to do contextual awareness and actually understand its location by mapping its 3D environment. And that's all happening real time with computer vision. That's loaded on top of the CPU and driven by the DSP as well. This lower robot here, we call it the Dragon robot. It's basically using both computer vision to basically identify the location of the target, identify if it's a toy or a ball or a rock, and then be able to sort it and put it in the corresponding bin through machine learning. So we're stacking on top of it layers of technology, but the underlying core chipset is the exact same chip that's in the superphones today. But we're enabling it a little bit differently. On the upper right, there's what looks like a GPS tracking system. It's using the traditional kind of breadcrumbs, and we're showing somebody tracking around both in a car and on campus. But it's actually using not one satellite signal. There's no GPS technology in this. It's using the camera to take a map of its environment and use markers to understand in relation to where the target is to where the marker was, and calculate where the location of the handset is. And we've got it to about a 1 meter accuracy in terms of in-building. And you take that and overlay it with real GPS SAT services, and you can do something really interesting. In the final video down here, bottom right, we're using 3D spatial mapping. So the ability to actually take a 3D render of a room and map that both for coordinates position and also for drones, for example, where we use that to do things like follow me or avoid and detect. So all these things you've seen potentially concept-wise, but these are services and applications we're actually rolling out now. And they're going to be available in broad scale across multi-millions of devices. The trick now is to figure out how to commercialize those and how to make real products that are differentiated to them. One of the other things that we spend a lot of time in is the FIRST robotics organization, and in particular our involvement in China. If you're not familiar with this, it's a fantastic way to get youth involved in both science and technology. There's about 350,000 students globally involved in it today, over 40 countries, and they have competitions basically in every major center, 3 of which I think this year are in China. So we spend a lot of time with this organization, and for us it's one of our ways to kind of take our technology and at the grassroots level kind of get it evangelized. I think we have a short video to show you guys too.
When you've got over 1 million smart, passionate kids that all have learned the power of technology, they have all learned what teams of focused people can do, you can be sure among them there will be this generation's superstars.
We've got a whole bunch of kids that are learning not only science and math, but also how to work together, how to cooperate, teamwork, gracious professionalism. The kids that go through this program have got it right, and those are the kind of people we're looking for at Qualcomm.
All of these have Snapdragon processors. The reason we're able to get better sensors is that we no longer have to rely on the processing power of the NXT. The phone has a much faster rate of processing, and so we can use better sensors that grab more points per second.
Our game challenge is called Recycle Rush. We have to stack totes on top of each other on a scoring platform. It's just inspiring to go onto the Jam's floor and see your robot working and doing well and doing all the mechanisms that you spent your whole season working on.
I think it shows a lot about our long-term commitment and how we really follow through with our plans.
The world really is open to you once you learn how to use this platform and use the Snapdragon technologies.
I think the Qualcomm commitment to the next generation of our control system will essentially define the next generation of this First Tech Challenge competition.
So again, if you haven't had the chance to be involved, I really encourage you guys to take the time to get your youth involved in the program. It's a great way to expose them to science and technology at an early age. The other last thing, most importantly, is we talked a lot about the technology and how we're taking what we're doing in mobile and applying it to other markets. What we're doing today is actually announcing the availability of our first Dragon board. The Dragon board was really developed for the community. It's designed for makers. It's taking one of our mid-tier chipsets, which is really high-performance computing power. Some of the things I showed you today are actually enabled on this platform, and making it available to makers to actually develop on. We announced the concept of this a couple months ago, but today's the first day we're actually commercially making it available. It's up on arrow.com. You can buy it today. and it's available for global distribution. The board itself is based on the Snapdragon 410 processor, which is a quad-core A53 V8 optimized CPU. It's running at 1.2 to 1.4 gigahertz. It has, most importantly, has integrated GPS, Wi-Fi, and connectivity already built in onto the board. So you don't need externals or peripherals or daughter cards. It has 1 gig RAM and 8 gig eMMC. It has USB, SD micro, and both fast and fast serial extensions on it, so you can actually shield it with Adrenos, so it's Adreno board compatible. So if the capability of this device, a lot of the things I showed you today, it's already going to be able to enhance that with the technology that we showed you. So we're really excited to bring this to market. I think hopefully you guys can take advantage of it and start building and innovating on your own apps. In terms of software support, at launch we're going to support Android. We've also done a lot of work to actually do a fully upstream distribution of Linux. Preliminary, our first release is going to be with Ubuntu. This is again available today through 96boards.com. The boards will ship natively with Android on them, but you can repurpose them for Linux. And we're also going to support Windows. You heard Dan mention the Windows initiative. They're doing great things at Microsoft. Both Windows 10 as well as the Windows 10 IoT Core will be supported later this summer on the boards. So you have a much higher performance board available and running multiple operating systems available to the community. Best of all, it's targeted towards an entry-level price point of really $75, and that's out of the box, ready to go. There's not much more you need than that. But again, if you guys are interested, please take time. We're also doing some booth demos later tomorrow and the next day. If you really want to get your hands on the boards, we actually have a workshop set up, and you guys can sign up for it, attend the workshop. You can get your hands on the board and actually do a project to develop a project that includes adding 2 or 3 sensors to the board. The board itself, I said, it has integrated GPS. So the ability to use one single board to do GPS tracking without having to reconfigure is a huge advantage. You see, this is a demo of them just doing a satellite. In terms of the satellites, it's locking onto 23 of them in the SAT service. But we have a lot of developers now in kind of pre-commercial stage using the board. The graphics support is Adreno 300, so it's a very high-performance graphics processor. We've designed some native games that actually will come pre-installed, or you can download them with the Dragon board. And this is kind of showing some of the capabilities of the graphics core. It also supports Miracast, so you can do wireless Miracast through dual display over Wi-Fi. So this is the information on the, oops. These are the information on the workshop that's available starting tomorrow. So I, again, encourage you guys, if you can, take time to come out and try out the new Dragon board. And we're looking forward to working with you guys and helping you take what we've done and innovate on top of that. Thanks very much. Sheshe.